As the HLS design flow is a new topic, its learning requires a step-by-step approach with several examples. The structure of this course is based on this assumption. This course is the second step towards using HLS to design logic circuits for FPGA, which its focus is on sequential circuits. In this course, I will take the HLS approach to explain the fundamental concepts in designing sequential circuits. I assume that you are familiar with the HLS-based approach to design combinational circuits, explained in the first course of this series. This course looks at FPGA from the high-level perspective, without going into the low-level hardware details. This course would give you the foundation of using HLS for digital design in Xilinx-based FPGAs to enhance your productivity compared to the traditional HDL design flow. The only prerequisite for this course is the high-level synthesis for FPGA Part 1 combinational circuit course. And you don't need to read any specific document. However, referring to Xilinx documents, especially Vitis High-Level Synthesis User Guide UG 1399, is recommended. For more examples and discussions about the HLS-based design approaches, you can refer to the highlevel-synthesis.com weblog site or the course GitHub site. If you have any questions or issues regarding the concepts and codes presented in this course, please refer to the Q&A section. In this course, you will learn how to use HLS design flow to implement sequential circuits, and how to work with the state-of-the-art software tools to implement arithmetic, logic, and control circuits on hardware. This is a practical course. Throughout the course, I will explain the concepts of FPGA structure, software tools, HLS techniques, and coding styles to implement several examples. This course comprises 4 parts. The first part is called Prologue, which introduces the course and its structure throughout 2 lectures. The current video is the second lecture. The second part is called Setup, which gives a big picture of the HLS for FPGA and its design flow, and how to install related software tools and set up the target FPGA board. It consists of 1 section including 5 lectures, from lecture 3 to 7. The third part explains how to develop sequential circuits using C++ language in HLS. This part consists of 11 sections and 77 lectures. Finally, the last part puts all explained techniques together to implement 3 exciting projects. It consists of 3 sections and 18 lectures. The course parts are designed to cover all classical concepts and techniques in sequential logic design for FPGA implementation. The first project implements a digital dice circuit. The corresponding section will explain 2 different techniques to generate a random number in hardware. The second project implements UART modules to exchange data serially between the basis tree board and a computer. The last project designs a logic controller to control the rotation of a stepper motor. Each lecture describes a single idea, which is presented through a couple of slides. The first slide tells the topic and the motivation. Then it follows by a few slides explaining the main ideas and concepts. After that, a slide gives the motivation of the next lecture by posing a question. This slide also creates a conceptual link between 2 consecutive lectures. Then I summarize the lecture contributions through a few takeaway messages. The last slide in each lecture contains a quiz that helps you to concentrate on the main idea. In this course, I have considered a Xilinx Basis 3 FPGA board as our target platform. Basis 3 is an entry-level development platform based on the latest RTX 7 Xilinx FPGA, designed exclusively for Vivado design suite. This board is cheap and accessible by almost all students, researchers, and individuals. However, the concepts and techniques explained in this course are valid for all other Xilinx FPGAs. What is the structure of the lab environment that will be used throughout this course? The next lecture will answer this question. The takeaway messages are: this course explains the fundamentals of sequential digital designs using the Xilinx HLS toolset. You don't need to have in-depth hardware knowledge to follow this course. Familiarity with the C++ language is necessary. The high-level synthesis for FPGA Part 1 Combinational Circuit course is the prerequisite to this course. Now the quiz question. Download the Vitis High-Level Synthesis User Guide UG1399 document and have a look at its table of contents.